Hi, my name is Bikash Sharma and I am one of the master's student studying process technology in University of Southeastern Norway, Porsgrunn. The topic of my master's thesis is sensitivity analysis of oil production models to reservoir rock and fluid properties. This thesis has been supervised by Professor Britt Moldestad and PhD candidate Ali Moradi. What is sensitivity analysis? Sensitivity analysis is the process of evaluating and analyzing the properties of rock and fluid parameters of reservoir. Why is it important? It's important because it increases the production of oil by enhancing and improved oil recovery methods. The time and cost investment can be controlled. And lastly, the delay in water cooling and water breakthrough time can be achieved by sensitivity analysis. It can be done by using many techniques, one of which is differential analysis technique, in which one parameter is changed, keeping all the parameters constant. The software that is being used to model the well in this thesis is Olga in combination with ROX. The various sensitivity analysis parameters that are used are viscosity, porosity, oil density, gas-oil ratio, and many more. The Norne oil field, which is located in the Norwegian Sea, is selected for the real case of this thesis. The characteristics of the well is seen in the table below. The reservoir fluid parameters are given with the values and their proper units. Similarly, reservoir rock properties are also found, which can be seen on the table. All the parameters and their respective values have been found. After that, the calculation is required for frictional pressure drop, the pressure drawdown, and the diameter of orifice of ICD. When all these are achieved, the development of the model is done in Olga with combination with ROX. The first we consider is ROX model, and we can say the drainage area is needed to be made. After the drainage area is made, a proper grid must be set for the model. We can see in the figure that the grid setting of the mesh is shown. The larger the grid setting, the longer is the processing time, and the smaller is the grid setting, the results are unsatisfactory. That's why it is necessary the grid setting must be optimal. Similarly, we can also feed the values for the rest of the parameters in the tabs in ROX. Then Olga model is made, and one of the major point in the Olga modeling is the flow component. We can see in the figure, in the flow component we have a production zone, and each production zone is divided into two imaginary sections, and each production zone consists of a packer which divides the zones. It consists of near well source which connects Olga with ROX. It consists of ICD valves which helps the fluids to enter inside the wellbore. It consists of leak which connects wellbore and production tubing from which the fluid passes. For this, simulation cases is required for all the parameters, and it is shown in the table for all the parameters and their simulation cases. In the first case, 20% of the value is increased from its base value, and in case 2, 20% of the value is reduced from its base value. A model base case is required for simulations. So in the figure we can see is the visualized model of the Norne oil field. The results of the sensitivity analysis can be seen in the chart, and from the chart we can see the most sensitive parameter in case of oil production was found to be oil density, while the least sensitive parameter was porosity. Similarly, for the water, the most sensitive parameter was initial water saturation, while the least sensitive parameter was gas-oil ratio. Rock compressibility had no effect at all. The work in this thesis can be extended where we can compare the two different wells for the real cases. Also, consideration of more parameters like skin factor can be done for sensitivity analysis, while the consideration of heterogeneous case can also extend the future works. Thank you.